Good evening, everybody. Welcome to the 5th One Health seminar for this fall. Thank you all for coming out. As in the past, to kind of start out with an introduction to One Health and what it's all about. But like we did last time, since Michelle Glitzer, one of our business students, went to the trouble of creating a video, I'm going to let her video speak for me instead. There's a really handsome guy that comes up in parts of that I know you'll want to hear him. Or not. All right, what happened to my sound here again? Not that one. There. Forget it. There.
And those interactions go back and forth. For me, One Health is a recognition that we as humans are a part of a global ecosystem, and that the more that we recognize that we have connections to the environment, we have connections to plants and animals, and those interactions go back and forth, the better off we're all going to be.
Really no one global problem can be addressed just by one discipline. That's impossible, and it's important to incorporate a plethora of approaches.
For a small university like us, we have this tremendous opportunity to work together to look at and solve, hopefully, some of the world's problems.
It's very easy to go someplace where a species is endangered and say, okay, we need to preserve this environment, but we need to know how that impacts people. So that brings in the humanities, it brings in sociology, it brings in psychology. How does it impact that local community, telling them they can no longer go into this area?
I try to encourage my students to go to One Health seminars. One Health seminars it's a speaker series where we invite experts, subject matter experts or writers or performers, people who do work that spans interdisciplinary projects.
The seminars themselves are designed to impact students from all of the colleges at university, so that we have people who are from sciences thinking about business sides, that we have people thinking about the psychological impacts of problems, as well as going, oh, well, this is an animal problem, this is a plant problem, it's a human problem, it's all of our problems.
Del Val is one of the leading organizations in the area, and also they're nationally and globally recognized for their One Health seminars. And something that I'm really excited about that we're going to be doing this year is One Health Week. So we'll be celebrating different One Health activities.
So our students get exposed to professions that might be new to them, and professions specifically that are multidisciplinary. And so maybe they can be part of the solution in the future by choosing one of those careers.
Yeah, students come here, they major in a particular area, and that's great. There's nothing wrong with that. They get to know that area well. But I think it's important that they recognize that people in other disciplines have something to offer.
If you want to learn more information about One Health at Del Val, it's simply delval.edu/onehealth.
Here tonight, we are very fortunate to have an individual I've known for several years now and have had a lot of interactions with that have all been positive. He is a great speaker, and he has the coolest title I have ever heard for a job. He is a Director of Applied Climate Science at the Department of Conservation and Natural Resources here in Pennsylvania. So please join me in welcoming Greg Zarnicki, our speaker for this evening. You're going to have a great time.
Thank you, Reg. Thanks, everybody, for having me here tonight. What I hope to do is kind of take you on a little tour across Pennsylvania and talk about some of the impacts we're seeing in terms of climate change, what some of the projections are, and then some of the things that we are doing or plan on doing to kind of address it. Now, I've found it really useful when I speak to a group, because a lot people come from all different perspectives and backgrounds. I find it useful for the very beginning to do kind of a climate 101. So I'm going to take and put up maybe 4 or 5 slides. A lot of this will probably be familiar to you because you look like a highly educated, bright audience. But as I do it, kind of pay attention to the way I do it, because this is designed for folks that don't know what climate change is, or potentially don't believe what climate change is. Now, we're going to have plenty of time for questions at the end, but if I put something up on the screen that you have a burning question about, just yell it out and I'll try to answer it for you. So the first thing I always like to do is try to explain what the greenhouse effect is, because you'd be surprised how many people think the greenhouse effect and climate change are one and the same thing. Well, I mean, if we didn't have the greenhouse effect, we wouldn't have climate change. But if we didn't have the greenhouse effect, we also wouldn't be living here. So essentially, the greenhouse effect just refers to the fact that almost all the energy on our planet comes from the sun in the form of light. It strikes the surface of the earth. Some of it bounces back out into space, but some of it's absorbed as heat. Now, if we didn't have an atmosphere, that heat would then radiate back out into space. But thankfully, we do have an atmosphere, and there are gases called greenhouse gases that act like a blanket. It's an insulating blanket. Now, the one bad thing about this graphic is, and this is from the EPA, is it shows the atmosphere as being really thick, when in reality, it's very, very thin. It's very fragile. But you can think of those greenhouse gases as the fibers in a blanket that insulates the earth. And the more greenhouse gases you add to the atmosphere, the thicker the blanket gets, the warmer the planet gets. Now, there's a number of different greenhouse gases, but I'm going to focus on the primary one, which is carbon dioxide. Now, you can't get away from having at least some graphs and some data, so we're going to have just a few of these. So what I want you to do is kind of focus on this graph right here, and this is a historical look at carbon dioxide concentrations on the planet. So the bottom is years from near present back 800,000 years, and this is the concentration of CO2 from 0 up to the top line here is 450 parts per million, which is how we measure it. And if you take a look, you can see that carbon dioxide levels do fluctuate, but it's generally a little bit above 250, a little bit below 200. And for 800,000 years, it kind of did this routine fluctuation, and then boom, it jumped up. So something clearly happened to cause that increase. If you take a look at the graph on the right, this is 1950 to almost present day, and you can see it's really starting to ramp up. Now, this isn't quite current, so the current numbers are here. This is from October of this year, measured at Mauna Loa in Hawaii, because that's the kind of the standard measurement place. We are at 408.53 parts per million. And last year, we were 2.5 parts per million below that. So you can see it's going up pretty rapidly. So we're adding a lot more of the fibers to the blanket. So the question is, what happened? Where is this coming from? So this is a picture of the carbon cycle. By show of hands, how many people knew there was a carbon cycle? All right, most people. That's pretty good. A lot of times people will just look at me with a blank stare because they've never heard of such a thing. Don't worry about the arrows or the numbers. What I want you to take away from this graphic is that carbon occurs in 4 reservoirs on our planet. One is the atmosphere, one's the ocean, one is this green stuff right here, plants, animals, and us. For you Star Trek fans, carbon-based units, that's what we are. And the 4th reservoir is down here. It's the geologic reservoir. The arrows show you that we have carbon moving back and forth between this and this and this, but it wasn't until the 1800s that we began to tap into this geologic reservoir. And so we now have carbon coming from here, whereas previously locked up, entering the atmosphere and also entering the oceans. And so that's where this additional carbon dioxide is coming from. So if you take a look at this graph, this shows you global temperature, and this is the average line historically. This is the CO2 concentration, and you can see as CO2 goes up, so does temperature. So there's a direct correlation between carbon dioxide and temperature. And I won't get into all the details, but there are multiple lines of evidence that show that all the carbon that's being added to the atmosphere is coming from the geologic reservoir. There's an isotopic fingerprint to fossil fuels, so you can directly tie the extra atmospheric carbon to the burning of fossil fuels. All right, so now let's talk about what some of the impacts are. We're going to start by looking at global impacts, and then we're going to drill down to Pennsylvania. So the graph on the left shows you the anomaly in temperatures, and the way you interpret it is red and yellow means it's well above average, and blue is below average. And so you can see most of the planet is pretty yellow and pretty red, but especially the polar regions. The polar regions are really getting whacked with this temperature increase. And you can see the result of that in this graph here. So if you take a look, you can see this kind of orange line. That's the historic ice extent for a given date. And this particular date, this was July 21st of this year. You can see that there's a lot less ice than normal. And take a look at the ice that's there. The white ice is ice that's of a normal thickness. The blue ice is of much thinner ice. So you can see we have a lesser extent and we have thinner ice. So why does that matter? Well, if you take a look at this graphic, this shows you what's called the albedo effect. And if you take a look here, you'll see that when sunlight comes in, it hits ice with snow, 90% is reflected back into space and not absorbed, not converted to heat. Only 10% goes to heat. But if you jump up to open water, when the sunlight hits open water, 94% of that energy is transferred to heat. And so the end result is you have a positive feedback loop. The more water that's exposed, the more ice that melts. And so you get the significant increase warming in the Arctic. So you still might be saying, well, we don't live there, so what? Well, that has a direct influence on our weather patterns down here. So this graphic shows you the jet stream. And if you take a look, this is a normal jet stream. It's kind of a straight line, almost a straight line, and it moves pretty quick. And it's the jet stream that drives our weather systems, storms and things like that. It is driven by the temperature difference between the Arctic and the equator. And as that temperature difference decreases, then what happens is the jet stream starts to slow down and it wobbles all over the place. And so you get cold air coming down south and warm air starting to move up north. And this is happening year-round, but it's really noticeable in the wintertime. This is a graphic that shows you the polar vortex, which the media uses in the wrong way almost always. But the polar vortex is this kind of circular wind that used to be held in check by the jet stream. But because that temperature difference is decreasing, we get this wobbly jet stream, and you have cold air plunging south, warm air plunging north, and that's why over the past several years, it was not uncommon for it to be colder in Miami than it was in Juneau, Alaska. You're getting some really weird stuff going on. You're getting temperatures in the Arctic during the summer that are approaching 90 degrees. So really kind of messing up with the transport of energy around the planet. So that's why we say what happens in the Arctic doesn't stay in the Arctic. It has a direct impact on our weather. So let's take a look at temperatures in the U.S. So we're starting to drill down now. So this graphic shows you, this isn't projections, this is actual temperature anomalies. And it shows you that most of the country is pretty red year-round. The top is annual temperature, the bottom is winter on the left, summer on the right. And you can see particularly during the wintertime, we're seeing really significant increases in temperature. Now these are projections for what's going to happen. Thus far in Pennsylvania, we've increased 1.8 degrees Fahrenheit, and we're already seeing implications of climate change in Pennsylvania with just 1.8 degree increase. So the way you interpret this graph is, on the left is what they call the lower scenario. This is the best case scenario. This is what would happen if we today stopped all carbon emissions, which obviously we're not doing. On the right, this is the worst case scenario. This is what we're doing right now. So this is the middle of the century, the end of the century. So let's just look at this one. Best case scenario, by the middle of the century, we're going to see a 4 to 5 degree temperature increase. That's 2 to 3 times more than we've already seen. But we're on track to actually see this, where by the end of the century, we could see in parts of the state 8 degrees, 7 to 8 degrees or more temperature increase. This is average temperature. So this is kind of hard to wrap your head around. It's kind of nebulous, you know. So what does 8 degrees mean? Well, we'll put it in a little more concrete term here. There's this really cool website called 1001 Blistering Future Summers. And it looks like what a city will feel like by the end of the century. So I put in Philadelphia, because that's the closest city I could find to where we are here. Right now, the average summer temperature, not the high, the average summer temperature is 85, a little above 85 degrees. By the end of the century, we're on course to have an average temperature of almost 95 degrees. So Philadelphia or here will feel like Texas, Harlingen, Texas, which is down on the border with Mexico. So you might say, I like warm temperatures. But think about the animals that live here, the plants that live here, the health impacts of having temperatures like that. It would be catastrophic. And if you're interested, when you get home, you could call up this website and plug in your hometown and see how it's going to feel by the end of the century. So this graphic shows you projections for high temperatures. I just showed you the average. So let's take a look at Philadelphia, which is right here. And so historically, Philadelphia had fewer than 20 days a year that were 90 degrees or above. These bars, the yellow ones, are best case scenario, worst case scenario as we go through the end of the century. So by the end of the century, worst case scenario, Philly's going to see almost 90 days, almost 3 months out of the year, it's going to be 90 degrees or above. And that's the track we're on right now. And then worse than that is if you take a look at this little box here, it shows there could be 26 days a year, almost a full month where it'll be above 100 degrees. So that's the track we're on now, which needless to say isn't too good. So what are some of the impacts of this? Well, as you probably know, warmer air holds more water. And so it's leading to changes in precipitation. Overall, we've seen about a 20% increase in general precipitation across Pennsylvania. But the way the precipitation is coming has changed drastically. So if you take a look at this graph, this 55 represents 55%. That's the percent increase in very heavy rain events, those that only occur 1% of the time. So in the Northeast U.S., 55% increase, but if you drill down to Pennsylvania, we've seen a 71% increase in very heavy rain events. And when I go to give a talk, I almost always, if I ask, has anybody here noticed that we're getting heavier rain events? And everybody notices it. It's something that's very obvious. So what are some of the consequences of that? Well, this is a photograph from Loyalsock State Forest. There was a road here. That's a culvert, and that was the guardrail. And you can see it's all washed out. In our Loyalsock State Forest, we had 2 1,000-year rain events in a 5-year period. That's something that should happen every 2,000 years. We had it happen in 5 years. So we get these big named storms, tropical systems that come through and cause these kind of situations. This photo right here is from Interstate 83 between Harrisburg and Lancaster. And this is not from a named event. This is from a thunderstorm that developed last summer on a Friday night as people were driving home. In a period of 2 hours, they got half a foot of rain because the storm developed and didn't move. Once again, remember that slow, wavy jet stream? And so even though those vehicles are sitting in all that water, it's nowhere near a stream. It's not an area that's prone to flooding. The ground just couldn't accept that much water. So it's not just these named storms, it's storms that kind of develop and don't move. And this photo up here is a picture of the Appalachian Trail in Caledonia State Park. That section of the trail is washed out 5 times because of these heavy rain events. So they're actually looking at relocating part of the trail. So those are some of the implications of heavy rainfall. Once again, warmer air holds more water. But it's not just, water isn't just an issue when it comes to precipitation. We're also seeing really crazy changes in lake levels. So I told you we're going to wander around the state. This is from Presque Isle State Park, which is in my hometown of Erie, Pennsylvania, which is as far from here as you can get in Pennsylvania. It's up on Lake Erie, kind of halfway between Buffalo and Cleveland. And this is our most visited state park. More people visit Presque Isle than visit Yellowstone every year. And you'll see here, this is high Great Lakes levels. The Great Lakes are at their highest level since it's been recorded. And so it's causing all kinds of problems. Most of the trails were closed. These are houseboats. They're primarily owned by people from Pittsburgh who come up to Erie and just kind of like to sit on the water. The boats don't go anywhere. They're just kind of anchored there. And so the way it works is you walk onto the dock and you take a little rowboat to your houseboat, but the water was so high this year, you had to take a boat to get to the dock, to get to the boat, to get to your boat. That's how high it was. And these are gas docks. To get to the gas dock, to put gas in your boat, you needed hip boots because the docks were underwater. It was really quite the sight. So the projections for the Great Lakes are rapidly changing high and low water levels as a result of climate change. And a lot of our inland lakes are starting to see these crazy fluctuations as well. So let's turn to a different kind of precipitation. We're going to talk about snow a little bit. There has been a significant decrease in persistent snow cover in Pennsylvania. So this graph shows you across the country, the red dot indicates that there's more rain and less snow. The bigger the dot, the bigger the difference. And you can see there's a lot more red dots than blue dots. The graphic here shows you historic persistent snow cover of 1 inch or more. This is by the middle of the century and by the end of the century. We're already seeing really significant decreases in this persistent snow. So as an example, some of the implications of that, it has wildlife implications, it has water storage implications, and recreation implications. I'm going to talk about that in a bit, but in our state parks, winter recreation is a big part of what we do. As an example, up in Erie, we used to have a cross-country ski concessionaire, and that was one of the most popular activities, that and snowshoeing, and they don't even rent them anymore because there isn't enough snow, enough persistent snow. Now, with that said, climate change is kind of weird in that not all of the consequences are intuitive. So I just said that there's not nearly as much persistent snow. But these are pictures from my hometown of Erie from one winter ago, where they had 200 inches of snow during the winter, and 6 feet of that fell in a 2-day period. And so this is what your front sidewalk looked like. This is what you had to do with your roof. When I lived there, I used to have to shovel my roof routinely, but we didn't get 6 feet of snow in 2 days. And the reason is because of this. This is lake effect. So you can see these blue streamers here. Lake effect snow comes over open water. So if you have cold air kind of running down from the Arctic because of that wavy jet stream, and you have open water, it just sucks all that moisture up and it dumps it. Now the weird thing about this was not only that they got so much at one time, but in 2 weeks it had melted. It was gone. And it used to be the snow would stick around for a long time. Another thing to note here too is you can see these bands of lake effect snow are coming much farther from the lakes than they used to. Interstate 80 is ranked as one of the 5 most dangerous roads in the U.S. because of snow squalls now during the wintertime. So just 2 years ago, they started a new kind of winter weather advisory, snow squall warnings here in Pennsylvania because they crop up so quickly. This shows you the ice cover from the time period when 6 feet of snow fell. Normally, the lakes would be covered with ice, and you can see the green here is just a little bit iced. It was wide open water, so there was a lot less ice cover. So climate change is kind of weird in that it's, it's not that A leads to B leads to C, but A can lead to B and A can lead to C. And people don't always understand that. It's like that one senator in Norway who brought the snowball into Congress and said, you tell me climate's change and look at all the snow that I just got outside. It's not that simple. It's a very complex kind of situation. All right, so let's talk about some other impacts. So the impacts aren't just in terms of temperature and precipitation. It also affects the natural world. So invasive species, which I imagine you guys are somewhat familiar with, almost all do better under a climate change scenario. So on the left is a photo of kudzu. Kudzu was known as the vine that ate the South. People associate it with the South. Those photos I took in Lebanon, Pennsylvania. So we have kudzu in more than 60 places in Pennsylvania now where it's growing, it's flowering, and it's making seeds, and the birds like to eat it. So kudzu could become a bigger issue for us. On the right is a photo of the hemlock woolly adelgid. And the adelgid is an invasive insect pest Historically, it was kind of confined to the southern part of the state because they don't like really cold winter temperatures. But because our winters aren't as cold as they used to be, it is now found in almost every county in the state, and it leads to the death of hemlock trees. Now, hemlocks are what cool and shade most of our cold water streams, and so there are impacts associated with that. So the hemlock is our state tree, and that state tree shades those streams that contain our state fish, the brook trout. This graph shows you projections from the EPA as to what's going to happen to our cold water streams. So cold water streams is where we find the brook trout. So on this side, it shows you that all our cold water streams are red. So they go from cold water fisheries, which are these guys, the trout and the salmon, to bass and bluegills. We lose pretty much all our cold water fisheries. That's the worst case scenario. That's the path we're on now. Best case scenario shows you we lose most of them, but we retain some up in the Poconos and down in the Laurel Highlands. But either way, it doesn't look terribly good for our cold water fisheries. So climate change is leading to a decline in our state tree, which is leading to a decline in our state fish. Now, there are some other kind of counterintuitive things associated with climate change, and one of them is growing season. So if you take a look at the map, it shows you how many days the growing season has increased across the country. You can see it's about 10 days for us here. And if you have a backyard garden or you're a farmer, this can be a good thing. But there are also some negative consequences of that, and that's what this photo shows you from one of our state forests. You can see the nice green lush trees, and in the middle it looks kind of brown. That's frost damage. So we're seeing a lot more frost damage because what happens is you get these really warm late winter days or early spring days and the trees bud. And then you'll get a frost and it kills the bud. Now it doesn't kill the tree, but what it does is it prevents the formation of seeds or nuts, so that it impacts wildlife food. And it allows a lot more sunlight to reach the forest floor, which tends to dry it out and changes what grows there. 2 years ago was one of our worst frost years, and we had more defoliation in Pennsylvania due to frost than we did due to gypsy moss. And this is a problem, and it's been growing significantly. All right, so I've been talking about impacts on human natural systems, but let's talk a little bit about disease, because this is One Health after all. And I have to say, this is the first time I've ever gone to a presentation where somebody wore a hat that said deer tick, since we're talking about Lyme disease here. So this is a graphic that shows you Lyme disease thanks to deer ticks. At the top is 1996. This is 2017, which is when the most recent data was available that I could find. You can see it's really spread significantly. Lyme disease is directly tied to climate change because the ticks stay active in many places year-round. They produce a lot more little ticks, and so the disease spreads a lot more. These bars show you confirmed and probable cases, and I'll just point out 2017, almost 30,000 cases. Pennsylvania accounted for almost a third of those. We lead the nation in Lyme disease. For my department, it is our #1 workman's compensation claim. I've had it twice, and I don't even get out in the field that much anymore. It's a really common issue. But it's not the only vector-borne disease that we have to deal with. We also have to talk about mosquitoes. And so there's a number of things up on this screen that I'll kind of draw your attention to. So you know that mosquitoes potentially carry diseases. One of those diseases is West Nile, and that's carried by a number of our native mosquitoes. West Nile was the worst ever in Pennsylvania last year. There were several people that died from it. In Harrisburg, where I work, we had many infected birds. In the middle of the day at lunchtime, you would just have grackles walking up and down the sidewalk, totally disoriented. It was a really common situation. But it doesn't just affect people. This is our state bird, the ruffed grouse, whose populations have drastically crashed. And it's a direct result of them being very susceptible to West Nile virus. So here, another good One Health tie. Its impacts on human health and on animal health. So I talked about the state tree is in bad shape, the state fish is in bad shape, the state bird is in bad shape. I think the only thing we can count on is our state fossil, the trilobite, is probably going to be okay. All right, so it's not just the West Nile disease that we have to be concerned about. So let me draw your attention to this picture here. This is a measure they call disease danger days. This is for Philadelphia. And what it shows is, since 1970, the number of days per year that mosquitoes are active has increased, in this case, 2 weeks. There's a full 2 more weeks to mosquito season, 2 more weeks for these diseases to kind of spread around. In Erie, we kind of lead the state. The mosquito season there is a full month longer than it used to be. So it's not, Joe, just our native mosquitoes that are an issue. It's this guy right here, and you have probably encountered it, maybe you don't know. This is the Asian tiger mosquito. It's an invasive mosquito. This is the range right now. You can see it's definitely in this part of the state. It's small, it's very identifiable by those stripes, and it bites during the day. They come out during the day, they bite hard, they bite fast. Unlike other mosquitoes, which are primarily active at night. It carries West Nile, but it carries a bunch of other nasty things like potentially Zika virus, chikungunya virus, dengue fever. There's more and more emerging mosquito-borne diseases. Now, the scariest one this year, and you probably heard about it, was what's called triple E, Eastern equine encephalitis. 3 people died in Pennsylvania this year from it. It is fatal in 30% of cases, and in many of the remainder of cases of people bitten by it, they have some kind of permanent neurological damage. So mosquitoes are a big issue, especially for us, because we have state parks and we have campgrounds, so we're looking a lot more at mosquito control. So let's talk about plants and animals and how they're going to respond to this. So there are 3 primary responses. The first is they're going to adapt to climate change. And so it shouldn't surprise you, for example, that white-tailed deer are probably going to be fine because they're found from the Florida Keys all the way up to northern Canada. They have a broad range of conditions they can live in. The other critter you see there is a timber rattlesnake. And it looks like the timber rattlesnake might actually do better under a climate change scenario. We've done a climate vulnerability analysis for over 100 species in Pennsylvania, and there are some that are critically at risk and others that are going to do okay. So adapting is one possibility. The other is that you're going to get up and move because it's just too warm here, I'm going to go somewhere else. And so you have to be a mobile species. Now, birds are a good example of a mobile species, but they have to have a place to go, and they have to have a place to live, and they have to have something to eat. So it's not as simple as, oh, I'll just get up and move. But generally speaking, birds are better off than some other things. Then you have those critters that have very limited ability to move, and they have very specific kind of habitats and life cycles. And I have just 2 here as examples. Both are found in this part of the state. On the left is the bog turtle, and on the right is the spadefoot toad. Both of them are little critters. The bog turtle lives in specific kinds of wetlands. And as you can imagine, it would be very difficult for the bog turtle to kind of get up and march 50 miles to the north, particularly because there are a lot of roads and other impediments in the way. The spadefoot toad spends most of its time living underground. It only comes above ground when there's really heavy rains to reproduce, to feed, and it goes back underground. So they have really unusual life cycles and very specialized habitats. Those are the hallmarks for a species that's not going to do well under climate change. Other examples are a lot of amphibians are very much at risk in Pennsylvania and across the country, and freshwater mussels are also highly at risk for climate change. So are we seeing any of this happening yet? And the answer is yes. So the graph on the left shows you just a few of the bird species that the Audubon Society has looked at to see how much farther north they're found during the wintertime. Now, on average, almost every bird in North America shifted its range somewhat farther to the north. The turkey is found 400 miles farther north than it was 30 years ago, and the robin's found 200 miles farther to the north than it was just 30 years ago. And then you have this guy right here, red-tailed hawk. I'm sure you guys have noticed them. They're around. Pretty common. They used to migrate. In the wintertime, they would move down south, but for the most part, they don't anymore. They stay here because with a lot less snow cover and warmer temperatures, they've got food year-round. So we're seeing changes in migration patterns as well. And then we have this really cool case study of one species moving in and another species moving out. And so the black-capped chickadee used to be native to this part of the state. I'm sure you don't have them here anymore. You might think you do, but what you have are Carolina chickadees. They look a lot alike. And what's happening is you have the southern Carolina is moving north, and the black-capped chickadee is moving north ahead of it. And there's this yellow line. This is the zone of hybridization, where they're coming together, they're hybridizing, and it's moving a kilometer per year. It's a very heavily studied example of species that are beginning a replacement regime. And this is a clutch of hybrid chicks that I took up at Hawk Mountain 6 or 7 years ago. So is this a bad thing? I don't know. Is it a good thing? I don't know. But it shows you things are happening. There's changes that are beginning to occur. I see a question back there? I believe the story is that they can reproduce, but they're still, for some reason, they don't persist very long. So as that hybridization zone continues to the north, the Carolinas take their place. That's a very good question. All right, so it's not just animals that move, it's also plants. And so for this example, I'm showing you black cherry. So this is the current range of black cherry. It's the most economically important tree in Pennsylvania. We lead the world in its production. And you can see that this is a best case scenario, worst case scenario by the end of the century. Best case scenario, it retreats to just a certain part of the state. Worst case scenario, we're going to start to lose black cherry altogether. And so we're already seeing changes in black cherry, in sugar maple, any number of species. Pennsylvania is kind of unique in that we have a lot of northern species that have the southern end of their range here. We have a lot of southern species that have their northern end of their range here. And so we're kind of like the Mason-Dixon line of biodiversity. And so we're seeing that mix of species, and we're seeing things start to retreat to the north. All right, so now I'm going to talk a little bit about what we can do. So first of all, let me just kind of orient you. If you don't know who DCNR is, the department I work for, we manage state forests, 2.2 million acres, and 121 state parks. So by show of hands, how many people have been to a state park in the past year? All right, good. I was hoping I wouldn't see anybody with their hand down, but there's a few. You need to get out and check out our state parks. We're going to talk about them, but our state parks are very important for kind of connecting people with nature. So what we can do is we kind of two strategies. One is adaptation, which is dealing with the impacts or preparing for the impacts of climate change that we know are coming no matter what we do. The other is mitigation, which is reducing greenhouse gases either by emitting less or removing some from the atmosphere. And I'm going to talk about both of those. So I'm just going to kind of give you an idea of some of the things we're looking at and break it into pieces. So I want to talk about infrastructure because within DCNR on our lands, we have over 130 dams. We have thousands of miles of roads, 700 bridges, hundreds of buildings. And, you know, we're talking about these really heavy rain events. That is really beginning to impact us. So you saw this picture previously. This is a culvert, the traditional design. And this is an adaptation strategy. It's a different kind of culvert. Now, this isn't the same place, but this is what we're starting to do now. These are bottomless culverts. And so you can see it's much more heavily armored, but just as importantly as that, this is a tube. It's a pipe. This has no bottom. So over time, this, because of the flow of the stream, would eventually erode down below, and it becomes perched above the stream, so the water doesn't connect. That will not happen. So you have continuous movement of water, and what's most important is you have species, aquatic animals that can move upstream. As the stream warms, those cold water species can pass through these culverts and try to find colder water. So that's one example of an adaptation strategy. We're looking at culverts and how we should design them. So traditionally, all our culverts were for 25-year floods. But a lot of places in the state, a 25-year flood happens every year now. So we're looking at making much bigger and different kinds of culverts. We're also evaluating whether we need some of the dams we have and taking and looking at trails and roads and say, if they're in a flood-prone area, first of all, can we move them somewhere else? And if we can't, can we structure them differently so they can become more resilient to flooding. So those are some of the things we're doing in terms of adaptation. Now let's talk about recreation, because this is a really big, important part of what we do. I already alluded to the fact that we have a lot less winter recreation, and that's true. We're having a lot more summer recreation. Now, this is Presque Isle State Park, once again, up in Erie. Our summer recreation season used to be historically from Labor Day to Memorial Day. That is now extended significantly because the summer lasts a lot longer. There are places in the state where you can go out on January and find a park full of people, and it never used to be that way. So that presents a lot of problems. Among them is that generally our parks are staffed by seasonal people. So we don't have rangers and other people out there in case something were to happen. So that's one thing we have to look at. But in addition to that, those parks, the resource doesn't get a break anymore. So you'll find that there are people on those trails or using those facilities year-round. And so when do you do your maintenance? When do you give the natural resource a break? So we're looking at things like, is there a carrying capacity for parks? At some point, do you close the gate on some of these parks? That's not something we do historically. And looking at other things that we can do to kind of minimize the impact on those resources. Now let's talk about conservation. And you've already seen these two graphs. And these two graphs show you that, we've got species beginning to move across the landscape. So historically, conservation has focused on one of two things: either keeping things the way they are or returning them to some former state. And oftentimes that conservation is based on a species approach. But that doesn't work in a changing climate because the conditions under which those species evolve are different now. So we need to look at things differently. So communities, which are assemblages of species, do not move, but individual species do. So for example, the chickadees that are starting to shift to the north. Not all the birds in that community are shifting to the north and at the same rate. So what we're finding is we're beginning to develop these new kind of novel ecological communities, mixes of species that we never saw before, and it's just beginning right now. So what do you do about that? Well, you kind of take a different approach to conservation, and you view a forest or a wetland or a grassland as kind of a stage. And you conserve the stage, but allow the actors to change. So we keep our forest as a forest, but we recognize that some of the trees are going to move in, some are going to move out, some of them are going to die off. You don't invest all your time and money to keeping it the way it was. You invest your time and money to ensure that it's still a forest and it has that same ecological function. And this is kind of an analogy. This isn't mine, but I stole it from somebody. It says we need to create arenas of evolution and not museums of the past. It's kind of a different way of looking at conservation. Okay, so in that vein, if you look at climate as it's changed over the eons, and it has, we've had ice ages where the glaciers kind of moved up and down, and species would ebb and flow across the landscape. Well, that's still happening, but the problem is we weren't here when that happened before. So it was easy for things to move across the landscape, but now you take a look, because of us, we have cities, we have fragmentation of our forests. This is a power line right of way. We have natural gas pipelines. We really have kind of chopped up all the habitat. So it makes it a lot harder for things to move. So we're putting a lot of effort in identifying how do you connect habitats. So state parks and state forests and state game lands are going to be a big part of that system, but we'll also have to look at private lands and some of the things we can do there. So identifying and conserving those key connections are going to be important. We give hundreds of thousands of dollars every year in grant money for land conservation. So we're beginning to take climate change into account and say, is this a good piece of land to fund in terms of habitat connectivity? And so this graphic right here, this is Lancaster County. It's their green infrastructure plan. It looks at places that are important for biodiversity and movement. And in Lancaster County, if you've never been there, it's pretty much flat and it's farms. And if you take a look at all of these areas that are identified as important are riparian corridors. They're streams and rivers. And that's terribly important when you look at habitat connectivity. In Pennsylvania, two things jump out. It's riparian corridors and it's ridge tops. And so those are going to be a big part of the habitat connections that we need to make. And now, one thing I'll point out to you, it says plant trees that will be better adapted to future conditions. So I'm going to put up a graphic that you can't read at all, but I'm just going to kind of give you an idea of what it says. This is from our climate change adaptation plan, which is on our website. And so what we did is we worked with a group called the Northern Institute of Applied Climate Science, and they broke the state down into physiographic regions, and they looked at all the common tree species to see how they would do. And so this is from the area we sit in now. And so I know you can't read these, but red arrows mean they're not going to do well. These are 2 climate change scenarios, best case, worst case scenario. And in green means they'll do better, and yellow the same, and in blue stars are new things. And so kind of drilling down for the area that we're in now, just in general terms, likely to decrease are black cherry, I've already mentioned that. Eastern white pine, sweet birch, and white ash. Ash is doing terribly anywhere in the state because of emerald ash borer, which is a pest. Likely to increase eastern red cedar, sweet gum, sycamore, and then you've got some things that you might not see right now that are starting to move in or are here in very low numbers. So one I like to point out, because it's really becoming a lot more noticeable, is American holly. It's really becoming a more significant part of the forested area in this part of the state. Most people think it's just something you plant in your front yard, but it is actually a native tree. So those are some of the changes that potentially you're going to be seeing here. All right, now we're going to switch gears to away from looking at how we can adapt to climate change to that other thing, mitigation. I'm going to kind of wrap up quickly with this. So I want to talk about forest carbon sequestration. So this podium right here, made of wood, was actually at one time atmospheric carbon. So you know, through the process of photosynthesis, plants remove carbon from the atmosphere and they convert it to wood and leaves and things like that. And if you look at a tree, 50% of its weight is actually carbon. Surprisingly, most of that is actually found in the soil beneath the forest floor, but it's a very significant way of taking carbon out of the atmosphere. So just in Pennsylvania, just the forests that we manage, we're looking at 4.7 million tons of carbon that we've sequestered. So what we're doing is we're looking at ways of making sure we don't lose forests, ways of increasing forests, and ways of managing it differently so the forests we do have sequester more carbon. So this is kind of a cool exercise that you could do if you were interested. There's a website you can go to. You identify a geographic area, and you plant some trees online. So this is from near my house. I live in Hershey, and so if any of you have ever been to Hershey Park's right over here. And so this is just a small floodplain. And what we did was we plopped some trees in there, 2 types, red maple and sycamore. And this shows you what kind of benefit that would have. So keeping in line with the One Health message, we plant just a handful of these trees, and those trees over the next 25 years sequester about 41,000 pounds of carbon. So it's a way of you identifying. You can do this on a site on campus or somewhere else, and you can see how much carbon is sequestered. It also looks at some of the other benefits. So for that same 25 years, they absorb almost 500,000 gallons of stormwater as well. So you can see there's real significant opportunities for planting trees and what they can do. If you take a look at Philadelphia, this is the a carbon equivalent in Philadelphia. The trees within the city limits remove 6.5 million tons of carbon. So planting trees, I can't emphasize enough, do great things. And I have just 2 slides left now. The last thing I'll mention is that we at DCNR are kind of walking the walk. We are putting in solar panels in a lot of our state parks, and our goal is by within 2 years that we will have 50% of our electricity come from solar. And we put them in state parks because we have 45 million visitors to state parks, so people can see how this works firsthand. And we are also converting our fleet to electric and plug-in hybrid electric vehicles. The car you see right there is the one I drove here. It's sitting in the parking lot. And we are switching our fleet over to these kind of vehicles. We're also putting electric charging stations in state parks. So if you have an electric car, you can visit a state park, plug it in, charge it up for free. We hope that by the end of next year, we'll have 43 of these stations within state parks across the state. So that was kind of a whirlwind look at climate change in Pennsylvania and some of the things we're doing about it. So I will open it up now for questions if anybody has any. Thank you. Did I cover everything? Oh. Questions?
So obviously solar panels are like really big. And so how are you accommodating the space that they need to take up without removing whatever natural habitat is there already?
It's a good question. Most of them are roof-mounted solar arrays, so they're on the roof of existing buildings. Some of them, though, are on the ground. In those cases, they are in areas next to existing buildings that right now are more turf or mowed areas. We don't remove any natural habitat to put solar panels in, but it's a very good question. You got one right here, Reg.
So throughout the presentation, of course, there were a lot of figures that are projections into the future. Are these all from a single source? Did you sort of crowdsource this information? And then, in your opinion, how, because there's always the implication of how accurate models can be and if they can accurately interpret what will happen because they can't necessarily take in all of the factors. I know I'm asking like two questions right now. But, so, number one, where's the sourcing of all of the, or at least some of these projection models? And then number two, in your opinion, what do you think is, you know, the viability of these projection models?
Okay, both very good questions. A lot of the graphics I showed you come from the U.S. Climate Assessment, which is a team of scientists from around the countries, mostly from universities, that do use a lot of models. We also have a lot of our models came from the Northern Institute of Applied Climate Science, which is at Michigan Tech. And any of them will tell you that models have their limitations. But the models have improved drastically over the past even 5 years. And so every time they do a national climate assessment, and they do it every 1 or 2 years, the models are rerun. And so they become more accurate over time. And what generally the statement you can make is, in almost all cases, if you go back and look at what the models project to what's happening now, they're all conservative. Things are actually moving faster and more, more severe than they project. But it's true that models have limitations. And in any of these models, that's the first thing they'll tell you, is that it's the best information we have available at this time.
One of the main reasons I bring it up too is because a lot of people that are not necessarily quote unquote believers or are not convinced enough of climate change, they bring up, oh, these models are just, they're models, the reality. So I guess a big part of it is, using these models, which are improving over the years, but also the actual evidence in front of us.
Yeah, you're right. And I think one of the most, convincing things is if you take the model and you work backwards. And it does show that they're actually, they're getting better. And, all those projections that we've been seeing for the past 10 years, almost all of them are coming to be. So, the people that don't believe, we probably will never convince them. And you hear this figure that 97% of climate scientists say this is real and we're causing it. And the analogy I like to use is, because the deniers will say, well, there's 3% that don't. I was just at a hearing at the Capitol a couple weeks ago where this panel was all scientists that were deniers. It was the craziest thing I've ever seen. But they cherry-picked a handful of people that don't agree. So if 97% of scientists say it's real, imagine you go to the doctor and you find out you have some really serious disease, and the doctor says you need to have an operation. And you say, you know what, I'm going to get a second opinion. And so you go to another doctor and they say, you need to have an operation. So you go to 97 doctors and they all say, you need to have the operation. Well, you keep going until you find 3 that say, don't worry about it. Now, who are you going to believe? It's the 97%. It's only logical, but as I said, hardcore deniers, there's nothing we can do to change their minds. But they're becoming a smaller part of the population.
Any other questions? So Greg, I got to ask you, over the years, I've known you for quite some time, and administrations within the state have varied, and I have guessed that in years past, your title would not have existed that you currently hold. But yet you've been working on this issue of what was happening to the state parks in Pennsylvania for quite some time. Right. So working in a state agency, you've got the good part of dealing with the entire state and trying to improve things not only for people today, but for citizens in the future. But yet you've had to deal with being within a political structure. How has that been for you?
It's a roller coaster. So I've been working on climate change issues for at least 10 years. Under Democratic administrations in Pennsylvania, it was full steam ahead. We had climate change on our website. Then at one point, honestly, it was when Governor Corbett came into office, policies changed. We had to remove the words climate change from our website. Those of us working on climate change, many of us were demoted and put into other positions. And everything we were doing was, I don't want to say underground, but the federal government at that time still required that a lot of our annual reports talk about climate change. So we would kind of do it on the QT, and we just kind of laid low. Then Governor Wolf came into office, and he's very supportive of this work. So that's why somebody pointed out to me the other day that I'm the only person in Pennsylvania state government that has the word climate in his title, and it's kind of unique. But we're going full bore again to do climate change work. We just joined a few months ago the U.S. Climate Alliance. So I don't know if you're familiar with them, but as you know, President Trump has pulled us out of the Paris Climate Accord. So 3 states stepped forward and said, you know what, we're still going to meet the Paris Climate Accord, and they formed what's called the U.S. Climate Alliance. So we were the 23rd or 24th state to join, so we are now part of that. So we're committing to the Paris Climate Treaty and working with other states, including, for example, Maryland, we're working with on forest carbon sequestration strategies. So things are looking very good now. Hopefully they will stay that way. I think that there is a momentum now, particularly involving young people, like a lot of you in the room, that you're tired of seeing us old people who screwed everything up, and you're going to do something about it. And I think there's a real impetus there that really makes a lot of us hopeful that no matter what the political situation is, things are going to still be moving forward.
Well, I think your presentation did something different than we normally see as well. And I got to say that I'm quite guilty of this myself in a classroom, talking about what the evidence is and what the impacts are. And then kind of going in, somebody's got to do something. You're actually doing things. You're applying the science and understanding what's happening in the state and then taking actions. And I personally, and I hope the rest of the audience, will applaud you for that.
Oh, thank you. We're trying.
If there are no other questions, I would suggest that this is a networking opportunity for you. Greg is willing to stay here all night, is that correct?
That's right.
And he's got a hotel down the road, so he doesn't care if he gets out of here at all. So please go down and introduce yourself and get an opportunity to meet with him. We've been quiet here, but take a chance to talk to him. Thank you.
Thank you.
Oh, and for community folks that may be in the audience, if you're not already receiving emails from me about One Health seminars, there is a sign-up sheet in the front. If you'd like to get emails directly from me, please do put your emails up here, and we'll make sure you hear about our next One Healths and the ones to come in the future. Thank you.